Virtual reality, or VR for short, is no longer just a concept from science fiction novels or movies. It's a technology that has become increasingly accessible and widely used in various fields, from gaming and entertainment to education and healthcare. But have you ever wondered how VR works? What makes it possible for us to immerse ourselves in virtual worlds and experiences? In this comprehensive guide, we'll delve into the science behind virtual reality and explain how VR works in simple language. Introduction to virtual reality. Imagine putting on a special headset, and suddenly you find yourself standing on the edge of a cliff, feeling the wind in your hair and the ground beneath your feet. Or perhaps you're exploring the depths of the ocean, surrounded by colorful fish and coral reefs, all without leaving your living room. This is the magic of virtual reality. At its core, virtual reality is a technology that uses computer-generated simulations to create an immersive, interactive, and often three-dimensional environment that users can explore and interact with. It's like stepping into a different world, one that can be entirely fictional or a faithful representation of the real world. The three key components of virtual reality. To understand how virtual reality works, we need to break it down into its three key components. The virtual environment. This is the digital world you enter when you put on a VR headset. It can be a game, a simulation, a 360-degree video, or any other type of immersive content. The virtual environment is created using computer graphics, audio, and sometimes even haptic feedback, like vibrations or touch sensations, to make it feel as real as possible. The hardware. VR hardware includes the devices you use to experience the virtual environment. The most essential component is the VR headset, which typically consists of a screen for each eye and sensors to track your head movements. Other hardware components may include hand controllers, gloves, or full body suits that allow you to interact with the virtual world. The software. VR software is responsible for creating, rendering, and controlling the virtual environment. It includes the game or application you're using, as well as the underlying software that processes your interactions and displays the virtual world on the headset screens. Now, let's explore each of these components in more detail and uncover the science behind them. The virtual environment. 1. Computer graphics. The heart of any virtual environment is computer graphics. This involves creating and rendering 3D models, textures, lighting, and animations that make up the virtual world. The science behind computer graphics relies on mathematics and algorithms to simulate how light interacts with objects, creating realistic visuals. Rendering. The process of rendering involves taking the 3D models and scenes created by developers and turning them into 2D images that can be displayed on the VR headset screens. This is where the magic happens. Powerful graphics cards inside the VR-ready computers perform complex calculations to determine how light bounces off virtual objects, creating the final images that you see in your headset. Frame rate. Frame rate is the number of images, frames, displayed per second. In VR, a high frame rate is crucial to maintain immersion and prevent motion sickness. Frame rates of 90 Hz or higher are common in modern VR headsets, meaning they display 90 or more images per second. Latency. Latency is the delay between your actions and the response you see in the VR world. Low latency is essential to create a seamless and immersive experience. Special sensors and algorithms work together to minimize latency, ensuring that when you move your head or interact with objects, the virtual world responds instantly. 2. 3D audio. In addition to visuals, audio plays a critical role in VR immersion. The science of 3D audio aims to recreate sound in a way that matches the visual experience. This means that if you turn your head in the virtual world, the sound should change accordingly, just as it would in the real world. Binaural audio. Binaural audio is a technique that simulates the way our ears hear sounds in 3D space. By using specialized microphones and algorithms, VR systems can capture and reproduce sound as if it's coming from specific directions. This helps you locate objects or events in the virtual environment based on sound cues. Head-related transfer function. HRTF. HRTF is a mathematical model that takes into account the shape and structure of your ears and head to simulate how sounds reach your ears from different angles. By applying HRTF to audio, VR systems can create the illusion of sounds coming from all around you, enhancing the sense of presence in the virtual world. 3. Haptic feedback. Haptic feedback is all about the sense of touch in virtual reality. While it's not as advanced as visual and auditory technologies, it's still an essential part of the VR experience. The science of haptics involves creating physical sensations or vibrations that mimic interactions with virtual objects. Vibration feedback. Many VR controllers have built-in vibration motors that can simulate sensations like tapping, knocking, or rumbling. When you touch a virtual object or surface, the controller can vibrate to provide a tactile response, making the interaction feel more realistic. Force feedback. More advanced haptic devices, such as VR gloves or exoskeletons, can exert force on your hands or body to simulate resistance, pressure, or even the weight of objects in the virtual world. This adds a new dimension to the sense of touch in VR. The hardware. Now that we've explored the science behind the virtual environment, let's take a closer look at the hardware that makes it all possible. VR headset. The VR headset is the most iconic piece of VR hardware. Head tracking. Inside the VR headset, there are sensors, such as accelerometers and gyroscopes, that constantly monitor the movement of your head. This is called head tracking and is essential for maintaining the illusion of being inside the virtual environment. Display screens. VR headsets have two high-resolution screens, one for each eye. Lenses. The lenses in the VR headset serve two main purposes. Second, they create a sense of depth and 3D perception by slightly offsetting the images shown to each eye, mimicking the way our eyes perceive depth in the real world. Optics and distortion correction. VR headset optics are designed to correct for any distortion or blurriness that might occur near the edges of the lenses.